Hi, everyone. I'll be back in a second. Where's everybody? Hi, everyone. We're going to just start in just 1 minute. Know that it's recording. It's already been recording. It's recording now. Okay, let's get started. Okay, let's get started. I hope you're all doing okay. I was curious, if you can unmute yourself and let me know, or how many of you are, or you can just put in the chat, how many of you have other teachers teaching online, live? Does anyone else?
I do.
You do?
I do.
I do.
I have.
This is my only class.
This is your only class? How many have it?
Yeah.
Does anyone have a full schedule? Does anyone have like a full schedule?
That would be insane.
I know. I'm just curious. Okay. My freshmen, almost all of my freshmen, I was like the only class that they were having, so I didn't know. Okay, great. So let's get started. I want to share the screen with you. A few things I want to say before we get started. I am recording now. Everything is being recorded. Oh, here we go. Okay. So I wanted to talk about just some things. Number one is, unless you contact me beforehand with a legitimate reason, and I'm not unreasonable, you're expected to attend every class. But know that it's also being recorded, so that's something. You can only log on using your STI account. If that's not the case, please log off and log on when this slide is completed. Okay. I wasn't aware until after the fact of the extent of the incredible disrespect by some participants on Friday. It was really sort of hurtful, and I was angry and I was hurt and I was really shocked. So I don't know what to do. I'm starting now by default. Every chat is being saved. And if I get any inappropriate language from anyone, I'm just going to copy it and send it both to your parents and to Mr. Moon. I really, really hope that doesn't happen again. I still am going to continue to allow you to chat to each other because I think I'd like you to see what others are saying. But for now, I haven't figured out how to save the participant list. So for now, we're going to simply type hi like 3 times throughout. So go ahead right now and just type the word hi. So if you're here, type hi so I have a record of it.
We type what?
Hi.
Hi.
H-I.
Oh, H-I. I heard pie.
You heard pie? Okay. No. Okay. Thank you. Okay, good. And again, if you're signed in as someone other than your STI address, please change that now. Okay, great. Okay, so we're in the process of learning how blood spatter is used to reconstruct a crime scene. And I want you to look over your notes, and I want you to type in 5 types of blood spatter evidence that we talked about yesterday or Friday, used by forensic scientists. Now, the example I'm giving you is one we didn't talk about. So this is my example for another one, which is, this is called a void. And as you can probably see, what a void is, basically, a void is when there's an object in the way and you have some sort of blood spatter with a clear area here. And what a void tells us is that there was an object here. We might be able to learn by its shape exactly what it is. So that's one. So give me 5 others that you learned about from last. Just type them in a row, just like void, comma, blum, blum. I'll give you like a minute or 2 just to look through your notes. Type them all in one. Type them, 5 of them separated by commas. Again, try to type them all at once. Okay, just 5 more seconds. We'll finish up. And I see, great. Okay, so I see a lot, right? I see swipe, I see wipe, I see radial spatter, I see arterial gushing or spurting, I see projected, I see cast off. Those are all awesome. Great. So what we started to talk about on Friday was how we can use blood spatter patterns to determine the point of origin. And that can be used, and in order to do that, we have to learn how to use the angle of impact. So actually, I'm just going to back up for a second. So what do we call, so first we had to learn to find this red circle. And what did we call this red circle? Does anyone remember?
Area of origin.
The area of origin, good. Oh, I wanted to say as well, I'd rather, when I ask questions, I'd rather, unless I tell you to do it in chat, feel free to unmute yourself, respond, and then mute yourself again. So absolutely. This is the area of convergence, right? Did you say origin or convergence? Whoever just spoke.
I'm gonna pretend like I said convergence.
Good. Okay, then you would have been right. Right. Not the point of origin. And what's the this is in 2 dimensions, right? This is in 2 dimensions. But now what we want to do is see, well, how far off the ground was that? And that's the point of origin. And I was a bit callous with you when I talked about it. I know I said, if someone is standing and then they're shot, if they're shot through the head, if they're shot through the abdomen, if they're shot through the leg, the area of convergence will be the same, but the point of origin will be different because it'll be at different levels above the ground, okay? So in order to do that, we have to measure the angle of impact. And what we talked about, Light, was that there's a relationship between the shape of the drop and the angle of impact. And we said that 90 degrees, which is the highest angle of impact you can have, and anything above that, below that, the drops are longer and longer. The longer the drop is, the lower the angle of impact, the lower at which it hits the ground, right? Again, feel free to ask questions if something comes up. So we have a really nice trigonomic tool to figure out, just by looking at the drop, what the angle of impact actually is. And this is the basis of it. If we're looking up here, we're looking at a droplet of blood as it hits the ground. And so I know that we think of drops as being these long rounded things, but actually once the drop forms and it starts dropping, most drops are pretty spherical, okay? And then it hits the ground here, and here's the drop now here. And if you then look from it above, here's what it looks like. And what we want to know is the angle of impact. So what's the angle of impact? The angle of impact is this right here, right? The angle of impact is what is it coming here? If it was coming straight down, it would be 90 degrees. What would roughly the angle of impact be? Just type in your chat. What would be the angle of impact for this roughly? Absolutely, this would be about a 45-degree angle, right? So now, we're gonna look at the drop to calculate that. And how do we do that? Well, because it's a right triangle, we can invoke trigonometry. So if we're looking down at the drop and we say this is the width and this is the length, that means this is the length and this is the width. Now you might say this is not the width. The width is going in the third dimension, which you please whoever could you please mute yourself, or I'll have to do it for you. Okay. Okay, so this is the length, and then this is the width. The width is also this. And the reason the width is both this and this is because the drop is spherical. So that when it comes down, this distance is actually equal to this distance. So now we can use trigonometry. The sine of theta is equal to the width over the length. The sine of this angle theta is equal to the width divided by the length. Similarly, the angle of impact, or theta, is actually equal to the arc sine of the width over the length. Again, the angle of impact here is actually equal to the arc sine of the width over the length. And that's it. If you take the arc sine of the width over the length, you have theta. And then you can go from there. So here's how we would do it. So let's take a look. This is a problem that's been solved for you. So you're going to do your own in a minute. Here is a drop. Now, the first thing is it coming from left to right or right to left? And we talked yesterday, right, or Friday, that it's coming from right to left. So now the question is, how do we measure the width and the length? So first we have to decide, where are we looking here, right? Because this drop is actually very complex. And what we do is we say, this is actually where we make this is our drop. So so this we ignore. And how can we justify that? How can we justify ignoring all of this? It's moving left to right. Sorry. I'm sorry. It's moving left to right. How can we justify cutting this part off and just moving and just looking at that? And the reason we can justify that is because this is what the drop looks like upon initial impact. This is what the drop looks like right here, right at the very minute it hits. This is the drop. This is the drop. This is a secondary thing that happens. The drop then slides to roll, and then it accumulates over here. So we can ignore all that. Okay. So this is little d, this is big D. So the first thing you're going to do is you're going to measure them. And if you measure them in millimeters, you've got that little d was 6.3 millimeters and big D was 18.6 millimeters. So therefore, we know the sine of theta is equal to little d over big D, which is equal to 6.3 over 18.6. And therefore, we also know that theta is the arc sine of 6.3 over 18.6, which is 20 degrees. So now, what I want you to do is either you have, take out a science calculator, or you can use your cell phone. And if you use your cell phone, you go onto your calculator and you simply turn it to the left, right? And it'll allow you to calculate the arc sine. And I simply want you to do is I simply want you to calculate if little d was 6.3 and big D is 18.6. I want you to be able to tell me, do you get theta equals 20 degrees? So go ahead and do that problem now. And then when you successfully do it, just type yes into the chat. And if you don't understand or you have any questions, just say them out loud.
How do you get?
Did someone ask something? Okay. Does anyone need any more time? If you need more time, just let me know. Okay, great. Okay, great. So that's the gist. So if you're given a blood spatter pattern, you can determine the area of origin. First the area of convergence, and then the area of origin, or the point of origin. Okay, good. Now, what do you do once you have that? Well, you have your blood stain, right? And you have your angle of impact, and you know the area of convergence. So what you do is you take your protractor, you get the angle, and then you take a string and you attach it to it. And that string will pass from the drop, and you go till you hit the area of convergence. And where it hits the area above the area of convergence, that will be the point of origin. So for this, in this picture, right, this is the point of origin, right? When you have several drops, right, what you do is you do it for each one. And you end up first with an area of convergence and then with a point of origin. And that's how that works. And what it actually looks like in less high-tech experiences, right, is in practice, what you do is you have string, you have tape, you have protractors, and you find the angle of impact for several of the stains. You tape a string at the base of each. You tape the string so that, and then you measure the protractor, you measure it, and then you see where they come together. And they should intersect at the point of origin, right? Okay, give me 1 second. Okay, good. So this is Dexter, and Dexter did a lot of this. And you can see there that that's exactly what he's doing. he's calculating points of origins at a really big crime scene. And there he is explaining it to someone. Okay, so what I want you to do now is just really quickly just type hey. I have to do this 3 times because I don't want anyone to just disappear in the middle of the meeting. So just again, just in the group chat, just in 15 seconds, everyone just type the word hey. Okay.
Hey, Dr. Hornstein,
Yes.
what's the difference between area of origin and area of convergence again? Sorry.
The area of origin is in 3 dimensions and the area of convergence is in 2 dimensions. So if we go back here, the area of, oh, that's not a good one. Let's do, I'm sorry, this is better. This one, sorry. The area of convergence would be on the floor right here. Is this Brian, I think? The area, the point of origin is once you take the angle of impact into account, they're going to go up, and then the point of origin is actually up here, right, above the ground. So that's it. One is above the ground and one is on the ground. Does that make sense, Brian?
That was
Whoever that
Jevin.
was. Sorry. Does that make
Don't-
sense? I'm sorry.
Yep.
Okay, so this is once I explain what you're going to do here, we're going to end class early. I'm not going. We don't need to do this as a class. You can do this on your own. So the first thing I'm going to have you do simply is I want you to measure little d, big D, and theta for each of these 8 things, and then you can submit that into Jupyter. Okay. I think we'll. Actually, you know what? Let's do the first one together. Everyone, go ahead and do. Wait, do you all have the sheet printed?
Dr. Horst,
No.
I don't have a
Yes.
printer.
No,
You don't.
Yeah,
I don't have a printer.
Oh, you don't have a printer. You know what? Oh, you don't have a printer. You can actually
Yeah.
do it from the screen. But yeah, you could actually do it right on the screen. Could you do it right on the screen?
I don't know.
We can, let me just see for a second. So, because it's a ratio, right? It's a ratio, so it shouldn't matter if it's exact. Yeah. So why don't we all do you all have rulers?
I don't
Okay.
have a ruler.
You don't have a ruler.
I'm not in the city. I have one.
Neither am I.
Yeah.
Oh, okay.
My sister's
So-
ruler I'm borrowing has only inches.
Okay, so let's do, it doesn't matter. Doesn't matter if it's inches.
Okay.
Because it's, again, it's a ratio,
But-
right?
Okay.
So anyway, here's what we'll do. Then forget about doing it together. I want you to do this sheet, these 8 of them, right? And the first decision you're going to have to make is where, let's look at this first one. Where do you cut it off? Do you cut it off here? Do you cut it off here? Do you cut it off here? And let's do the first one together. What you're going to do is you're going to cut it off here, and then you're going to measure width and length, and then just plug it in and get that. You should get that done really quickly. Okay? So that's the first part of the assignment. The second part of the assignment is 3 problems which utilize that, in which you're going to calculate the point of origin. So what we're doing here is you have 3 drops, and from 3 drops, this is pretty crude, but you'll get the idea. You'll get a feeling of it. It's much better to do it in class. You can calculate the point of origin. So why don't you all just read through this steps 1 through 7 for now, and then I'll answer any questions that you have about it. So go ahead and read it now. Make sure, because I'm going to have it, you're going to finish the rest of the class. You're going to do it on your own. You're going to do these 2 sheets, and then we'll talk about them tomorrow. So go ahead, and this is just the first of 3 problems. Go ahead and read this first problem and see if you have any trouble with it. And you can either say something or say something in chat or say something out loud if you have a question. You did not receive, oh, thank you, Jonas. You did not receive this. I'm going to send this as soon as class is over. I actually just, I was looking around at some old stuff and I found it. And I thought this would be perfect. So I will send this as soon as as soon as I end the meeting, I will send this. So go ahead and,
Wait, Dr. Hornstein, I'm confused. Which
Yes.
blood drop are we looking at?
All three.
we're all three.
All three?
Yeah.
Oh, okay. So all these 7 questions apply to all 3 of them. So we're supposed to have like 7 for each one?
What do you mean 7 for each one? Me,
Oh.
because it's problem 7? Because it's problem number, how far is off the ground is the point of origin? So,
I'm just saying, I'm kind of confused because there's 3 blood drops and it says determine the direction in which the blood was traveling. So do we just do like all 7 questions for each of these 3 blood drops?
okay, well, it depends on the question. So the first one says determine the direction in which they were traveling. So in that case, it's all going to be different. So the first one, you're going to want to draw a line and just show me which so whoever asked for this drop here, is the blood traveling from the top to the bottom or the bottom to the top?
Bottom top.
From bottom to
Good.
top.
Excellent. Okay, good. Excellent. Good. So then what you're going to do is you're going to draw a line of convergence. Does that, and I'll let someone go ahead and draw that. Where is the line? So what you need to do now is you take a line and you draw it. What just happened? Someone else is sharing. Who has the picture of Martin Luther King up here?
Oh,
Guys, could you please remove that?
It says it's Gordon. Yeah.
Gordon?
Yeah, I think if your camera isn't on, it uses whatever your like profile picture is for your Google account,
okay.
It's okay.
probably. Yeah.
So let me show you. So what you would do is, right, the first question is, this is in the way. I can't read it. You're gonna, let me get my sheet out so I can read it because I'm blocking the question. The direction in which the blood was traveling, right? In that direction, right? As you said, it's traveling, it's traveling in that direction. Right, someone just drove it in. Right, and then the one where the point of convergence, right? Where's the point of convergence going to be? Where those 3 lines come together, right, will be the point of convergence, right? So wherever they come, when you do that, right, you do that, you do that, you do that, right? And where they come together, that's your area of convergence. And then it asks you, measure the distance in millimeters from the area of convergence to the front edge of the blood spatter in a metric ruler. So you want to measure that. Thank you. Who's ever doing this? Who is that, by the way? Could you identify yourself? Who's doing this? Person? Identify yourself, please.
No. How is someone able to?
And I didn't even know you could do that.
Neither
So
did
please, I'm happy to get some help, but I need you to identify yourself. Could you do that for me?
Samantha said it's me.
Who's me?
Check the
Sammy.
chat.
It's Sammy.
Oh, it's Sammy. Okay, good, excellent. Okay, so thanks, Sammy. So this would be the area of convergence, and then it says measure the distance in millimeters from there to there, right? From the drop to the right, and then it says use a scale of 1 millimeter to 0. Oh no, this is a different problem. I'm sorry, I'm looking at a different problem. Then it says measure use a scale of 1 millimeter to 0.2 feet to determine the actual distance. And then what you're going to do is determine the angle of impact. And you're going to do the angle of impact for the 3. If you don't have a protractor at home, you're going to have to be creative. What is the angle for this? What is the angle for that? What is the angle for that? It'll be somewhere above the paper. And you're going to tell me just how far above the paper. And that's what you're going to put in here. Does that make sense? Any questions? Any questions? Okay, so if there are no questions, then what I'm going to say is we can go. And these 2 sheets are just put them in, but before you go, do not go. Just so I know you're here, type in adios, and then you go. And then we'll discuss these 2 sheets tomorrow. and continue and just type them in.
Ooh, so you didn't send the second sheet, right?
I'm about to, as soon as I get off here, I'll send the second sheet. I was making last minute changes to it, and I didn't have time before the class started. So I
Oh, okay.
yeah. I'm gonna clear the drawings. Okay, so if you said adios, you can go, and I will see you. I will see you tomorrow.
Yes.
Hi, Dr. Hornstein.
Hi. Does anyone have any questions before we go?
Yeah, one quick question.
Sure.
For bloodstain pattern analysis, those 2 worksheets, so you want us to do those and then turn them in on Jupyter, right?
Wait, say it again.
For the sheet that you posted on Jupyter earlier,
Right.
you want us to do those and then submit them, right?
Yes. So I want you to submit that, and I'm going to attach to that the other one that we just went over as well.
Right.
Which has 3
Okay.
problems.
Got you.
And that's what's going to be due for class tomorrow.
Also, Max asked if this will be posted on YouTube.
This will also be posted on YouTube. Every lecture will be posted on YouTube.
Oh, also, Dr. Hornstein, I don't think you need an account to like go onto your meetings. I think that was the problem for last time.
What do you mean?
If you just have the link or like the number, anybody can get on, if whether or not you have an account or not.
Yeah. So then it's hard to like figure out how to log in and then access. Because what you can do is you can use an ID, like a meeting ID. Like if you log in or make an account on Zoom with your Google account,
Right.
and then you can say join a session, and then it asks you for an ID, which is not the same thing as a link. You can also, it's more risky. Like I wasn't sure if it would work. It did for me. If you're logged into Zoom on your Google account online, and then you click on the link, it might automatically log you into Zoom on that session, but I'm not sure if that'll work every time.
So what's the advantage of using the ID? Because it won't let people get on?
I think then it's like you can log onto your account on Zoom online and then just click join a session.
The link that you provide has an ID within the URL though, so you can just.
Does it? Where's the ID?
It's like right before like everything else. It's just like a 9-digit, and then it's like a question mark.
Is it like zoom.us/j/ and then like an ID or?
Yeah, that like string of 9 numbers. That's the link. That's the meeting ID.
605738. Okay, that makes sense. So we can just do that.
Cece, I'm sorry. I'm feeling very thick. What was the problem? Why do we have to change anything?
No, you
I
don't.
don't think you can change anything, but it's just that. Yeah, it's
Well,
just that.
Aware of that people can come on the call without being logged into an account.
I didn't hear you.
Yeah.
It's just something to be aware of, that people can get on the call without being logged into an account that you could use to trace them. So like someone who's not in the class, if they had the link, could just join and you would.
Or someone in the class, and then you won't know that they're on their email or not because they don't need the
Or if
email
it's just
to log
somebody
in.
who has the ID and just wants to like mess with the class.
Got it. And what you're saying is that, but is there a way to prevent that?
Not that I know of. I'm just letting you know.
I think if we just, if you're posting it on the Jupyter and people don't share it outside of the Jupyter, it should be fine, right? Like people outside the class shouldn't access the link if no one's sharing it with them.
Well, unless someone has a friend.
Though. Yeah, that's a problem. Though. Somebody who has who can share it with their friend.
Right.
They
So
just get on.
Are you saying, guys, that the people who were being disruptive last time were actually people who were not in the class? Was that your impression?
No, it was probably someone in the class.
They're not in our class.
They were disguised.
They were what?
Disguised. They used
yes.
different account. Yeah.
Okay, well, let's
So
see. I'm going to talk to other teachers and see what they say as well. Okay?
Wait, Dr. Hornstein, is there a certain decimal place we should round to on the homework?
Oh, no. And the example, I rounded up to the nearest whole number, so you can do the same.
All right, thank you.
Okay. Thank you for your help, guys. I will see you. I'll see you tomorrow. Okay.
Bye.
Bye.
Bye.